Hi, I'm Seth, and my research was the comparison of water use and photosynthesis in three common tree species. Um, Urban trees provide important functions like carbon sequestration and photosynthesis. It's especially important in urban environments where air quality might be lower. We wanted to see how our trees performed in the most stressful time of the year during drought with peak heat stress and also the water stress. Um, we had our three species, our Douglas fir, red maple, and honey locust. We measured the rate of photosynthesis, stomatal conductance, and transpiration with an infrared gas analyzer, which measures the passive airflow with the gases that are coming off of the leaves. It has to be done pretty quickly after the leaf is cut from the tree because it stops performing pretty quickly. And then, the results of the research are as shows. We have our Doug fir performing relatively high photosynthesis throughout the course of the drought, but it had lower rates of stomatal conductance and transpiration because it's adapted to the drought here and stops moving water during the daytime once it senses that it's under stress conditions. And so at night is when it'll open up its stomata and move water around. The rates were relatively stable for the red maple, and for the honey locust, we had relatively high rates of photosynthesis, transpiration, conductance. It did not seem to be a very stressed tree throughout the course of the drought. And that's our conclusions. As temperature peaked over the course of the season, Doug fir had a higher rate of photosynthesis than the red maple, but stomatal conductance and transpiration were similar for it and the red maple. Our correlation suggests that conductance to CO2 water vapor declines with temperature in both Douglas fir, but water loss remains relatively steady. And then photosynthesis increased stomatal conductance in Doug fir, but maple had those stable rates. Something important to mention is that we had not a ton of samples of the honey locust, so that is potentially affecting our data. And at the end of the day, in terms of carbon uptake matter, the Doug fir was best able to balance water loss and carbon gain, while the other trees were a little more steady, as a result of the Doug fir being an adapted tree to this environment. And that's my project.